The topic of this video is creating polynomials using their characteristics. Let's look at a problem. Create a polynomial with the following properties: degree 3, leading coefficient 1, and for the root -1 it will have a multiplicity of 1, for the root +1 it will have a multiplicity of 1, and for the root 7 it will have a multiplicity of 1. Okay, so the first step in solving a problem like this is to add another column to our table. This is the factor column. And we'll identify the factors that go with these roots. All right, so when your root is -1, that means it must have come from a factor x plus 1. When your root is +1, it must have come from the factor x minus 1. And when your root is 7, it must have come from the factor x minus 7. Notice that in each case the multiplicity is 1, which means we only need one of each one of these factors. All right, so now we are ready to create our polynomial. So f of x equals our leading coefficient, which is 1, times all of our factors. So we have x plus 1, x minus 1, x minus 7. Anything times 1 is itself, so this simplifies to simply x plus 1, x minus 1, x minus 7. This is our answer in factored form. However, this problem wants our answer not just in factored form, but also in standard form. So we need to multiply all of these binomials together. Order of operations says that we should multiply from left to right. So I'm going to start by working on these two. I will use the FOIL multiplication method to multiply those two binomials. So this times that, this times that, and I will get x squared minus 1x plus 1x minus 1. And then all of that has to be multiplied by this x minus 7. Of course, I will simplify inside those orange parentheses first. All right, so one of the nice things about this is that the two middle terms here are going to cancel. They are opposites, and when you add opposites, they cancel to 0. So this part of our problem becomes 0, leaving us simply x squared minus 1. We still have our x minus 7. All right, now we're going to multiply this binomial with this binomial using FOIL, using the same approach as what we did a moment ago. So we're going to get x squared times x, which is x cubed, x squared times subtract 7, which is minus 7x squared, subtract 1 times x, which is minus 1x, subtract 1 times subtract 7, which is add 7. There are no like terms, so we're ready to write our final answer. F of x equals x cubed minus 7x squared minus 1x, which I'll write as minus x plus 7. This is our answer in standard form. All right, let's do one final check before we call this video done. Remember, we were asked to find a polynomial of degree 3. In standard form, the degree of a polynomial is the highest exponent of x needed. We have 3. That checks. In factored form, it's the sum of the degrees of each individual polynomial being multiplied. The degrees are 0, 1, 1, 1, and if you add all of that up, you get 3. The leading coefficient is 1, and that's what we see here. This is equivalent to 1x cubed. And of course, our leading coefficient here was 1. This gives us confidence that we've solved this problem correctly.